There's a monster at the edge of our universe. 66 billion times more massive than the sun. Its accretion disk shines brighter than 140 trillion stars combined. So vast, our entire solar system could vanish inside it, and still have room for more. When scientists calculated how it could have grown this large, this early, the math said, impossible. Like a creature born too soon, grown too fast, become too colossal. A cosmic monster the universe wasn't ready for. Scientists call it TUN 618. Black holes grow by eating gas, dust, stars. Entire solar systems pulled past the event horizon, compressed into nothing. But there's a speed limit to how fast they can feed. As matter spirals inward, friction heats it to millions of degrees, glowing so intensely that radiation pressure pushes new material away. This is the Eddington limit, a cosmic speed limit every black hole has to obey. If a black hole feeds too aggressively, it chokes itself, the radiation blowing away the very fuel it needs. This is how the universe keeps black holes in check. A normal stellar black hole, born from a dying star, starts at maybe 10 or 20 times the sun's mass. To grow into a supermassive giant takes billions of years of steady, patient feeding. That's the rule the universe wrote, and TUN 618 broke it. 1957, Tonantzintla, Mexico. Astronomers photographing the night sky noticed a faint blue flicker. They logged it as TUN 618 and moved on. For decades, it sat in catalogs, ignored, unremarkable. Then in the 1970s, radio telescopes turned toward it. The signal that returned shattered every assumption. This wasn't a star. It was a quasar, a supermassive black hole feeding so violently that its accretion disk outshines entire galaxies. When they measured its distance, 10.8 billion light years away, meaning we're seeing it as it was only 3 billion years after the Big Bang. The universe was still an infant, still forming its first galaxies, and TUN 618 was already 66 billion times the mass of the sun. That's when scientists realized something was deeply wrong. 3 billion years. That's all the time TUN 618 had to grow from stellar remnant into the most massive black hole ever observed. If it followed the rules, it should have needed far longer than the universe had given it. To reach this size that quickly, TUN 618 would have needed to feed constantly at maximum capacity, exceed the speed limit, grow without pause. The math doesn't work. Unless it didn't start small. Maybe it began as a primordial black hole, formed not from a dying star, but from density fluctuations in the first moments after the Big Bang. Already a million solar masses, already a giant. But we've never confirmed primordial black holes exist. And even if they do, it still doesn't explain how TUN 618 became this monstrous. The light we see from TUN 618 isn't coming from the black hole itself. Nothing escapes a black hole. What we see is the accretion disk, gas and dust spiraling inward at nearly the speed of light. Friction strips atoms into plasma, heats them to millions of degrees, forces them to radiate. TUN 618's disk outshines 140 trillion suns. If you stood billions of kilometers away, far enough to survive, the disk would consume your vision. A blazing wall of plasma, light bending around its edges, warped by gravity itself. You wouldn't see stars. You wouldn't see the cosmos. Just light, everywhere, overwhelming. And from the black hole's poles, Jets of plasma erupt. Particles accelerated to near light speed, blasting outward for thousands of light years. Each jet stretching farther than some galaxies are wide. A cosmic creature built from hunger itself. And feeding that light, consuming everything that spirals inward, is an event horizon so vast it defies scale. The event horizon of TON 618, the boundary where gravity becomes inescapable, spans 390 billion kilometers. If you placed it where our sun sits, it would swallow Mercury, Venus, Earth, Mars. It would extend past Jupiter, past Saturn, past Neptune and Pluto. Our entire solar system would fit inside with room to spare. And it's still feeding. Every second, more gas spirals past the point of no return. TON 618 grows larger. But here's what's unsettling. It never chose to become this. TON 618 is what its universe made it. Maybe TON 618 wasn't breaking the rules at all. Maybe it was born into conditions that shaped it into something we can't comprehend. The early universe was different. Denser, richer in gas, more chaotic. In those first few billion years, fuel was everywhere. Clouds of hydrogen collapsing, galaxies colliding, matter funneling into gravitational wells with nowhere else to go. Maybe TON 618 found itself at the center of that storm. It grew because everything around it fed into what it became. Quasars don't shine forever. Eventually the fuel runs out. The black hole goes quiet. But TON 618 is still blazing, still feeding. We're seeing it locked in a primordial feeding frenzy, surrounded by conditions that will never exist again. A creature shaped by an era we'll never witness. And now, it's ours to understand. If you could somehow survive near TON 618, floating billions of kilometers from the event horizon, you wouldn't just see something impossible. You'd feel it. Gravity would twist the space around you, distances warping, directions bending. Light from behind the black hole looping around it, appearing in impossible places, like reflections in a shattered mirror. Then the nightmare begins. Time would fracture, your heartbeat slowing, your thoughts stretching, seconds for you becoming hours, then months, then years for the wider universe. Anyone watching from far away would see you freeze mid-motion, trapped at the edge of forever. You aren't just witnessing extreme physics. You're standing before something that forces you to ask, if this exists, what else did we get wrong? In theory, there's a maximum size for black holes. Most models put that limit around 50 billion solar masses. TON 618 exceeds it. And that's when you realize, we said TON 618 was impossible because it didn't fit the story we wrote for how black holes should grow. We labeled it a violation because it broke our models. We called it a monster because we didn't understand. But TON 618 doesn't care about our models. And maybe the problem was never TON 618. Maybe the problem was thinking our limits were the universe's limits. Every boundary we draw is a reflection of what we understand right now, not what's actually possible. TON 618 didn't wait for permission to exist. It just became. TON 618 forces us to see something we didn't want to admit. The universe wasn't patient. Supermassive black holes formed almost immediately. Galaxies assembled in cosmic eye blinks, stars ignited, planets formed. The universe exploded into existence and raced to become what it is, structured, complex, capable of spawning life. And maybe that urgency means something. Maybe the universe had to become complex quickly, because complexity is what allows matter to look back at itself, to ask why, to wonder what it means. Right now, James Webb is studying quasars like TON 618, tracing how the first supermassive black holes formed, measuring the chemistry of the infant universe. Every observation brings us closer to understanding not just how TON 618 grew, but what it means that it did. We've spent centuries building models that say impossible, too fast, too early, can't exist. And the universe keeps showing us we were wrong. Not because the universe is trying to trick us, but because reality is larger than the boxes we build to contain it. TON 618 didn't break the rules. It only revealed that the rules were never as solid as we thought. We fear what grows beyond the limits we understand. We call it monstrous because it shatters what we thought was possible. But maybe the things we label impossible, the contradictions that break our models, aren't monsters at all. Maybe they're shadows of the potential we keep in the dark, showing us that the only limits that truly exist are the ones we're afraid to outgrow.